I love numbers so much, I like to scream them at the top of my lungs.
52!
Don't you?
Exclaiming a number like this, it's actually an operation. It's called the factorial. And what you do with it is you multiply that number and every number less than it, including itself, until you get to 1. So,
5!
for instance, is 5 times 4 times 3 times 2 times 1, or 120. So why would you want to yell a number at all? Well, there's some applications. For instance, there are these things called partitions, which is just the number of ways you can group a certain number of objects together. So, for instance, you can group 5 objects into like a group of 3, and then a group of 1, and then another group of 1, and then you could group those same objects into a group of 2, and a group of 1, and a group of 1. James Grimer has a great video on Numberphile talking all about this. Another thing, if you've studied Calculus 2, is in the Taylor and Maclaurin series, the denominator ends up becoming n factorial. Here it is in the general case, because the next subsequent each subsequent term in the series, the denominator gets multiplied by the next positive integer. So that's where that n factorial comes from. Where I believe most people will have seen the factorial in the wild is the P and C functions, or the permutation and choose functions, the way to order or group things together. And I don't want to go too in depth with this and turn this into an entire lesson about P and C, but somewhere along the line you probably ran into a calculation that looks like this. And no, I'm not about to write all of those factors out and multiply them all together, but what I can do is this, and then we can cancel out the
97!
common factors on the top and bottom, and then very quietly multiply the rest. Now, there's really not that many identities or shortcuts or properties of the factorial, unlike some other repeated multiplication shortcuts. I mean, the nature of the operation is rather limiting. You need to want specifically positive integers, multiplying them sequentially until you get some sort of predetermined terminating action. But it's nice to have this shorthand for the times that they do come up. Since this is more of a subjective favorite numbers type video, I didn't do any extra research into this topic, so there's probably some really cool applications of factorials that you're screaming at your screen right now trying to tell me. But I felt like the nature of a video like this was that I talk about why this concept resonated with me in the first place. So, I've been playing card games pretty much my entire life. And, 52 factorial is the number of unique ways that you can arrange a deck of cards. I mean, that kind of makes sense. There's 52 cards in a deck, but why is it that simple? Why is 52 factorial the only thing you need to do to find out the number of unique arrangements? Well, let's start smaller first and show you this application of the factorial operation, which is the number of ways you can arrange a set of objects.
For instance, I can arrange or permute 3 unique cards 6 different ways. This is a direct link from 3 factorial is equal to 6. For higher input values, you could simply list all of the arrangements just like this, but Here's something I figured out that helped me understand the deeper fundamentals of why this relationship between factorials and permutations even exists. When you add on a fixed object, it doesn't change the number of arrangements of the previous factorial value. It's just a spectator watching the original 3 cards do their routine. Makes sense. But when I include the 4th card into the mix, I noticed that now I have 4 different ways to create a 3 factorial ordering, where each card is sitting out one of these arrangement possibilities. 4 lots of 3 factorial is just an expanded form of 4 factorial.
So, when you open a new deck of cards, yeah, of course, I don't have any nails for this. Haha! Success! It comes in a pre-arranged form, like this. Oh, there's some jokers that I forgot about. Try this along with me, actually. Go get a deck of cards. It doesn't have to be new, a used deck will be fine. And give it a shuffle. Math says that 7 non-specific shuffles is sufficient enough to randomize a deck of cards. Like, they've done studies and whatever. And what I mean by non-specific is you're not doing something like this, where you're alternating the cards. That's just reordering the cards. In fact, a super fancy way of doing that, trust me, I'm not this cool, is you take the deck, you do what I like to call a zipper shuffle, where you interlock the cards exactly. Oh, that's pretty darn close. I'm not perfect, but the idea is you do that alternating thing. If you do that 7 times in a row, you'll get back to the original configuration that you had started the zipper shuffles with. Math! And you don't have to do this if you want to. You can do a smoosh. These are always fun, right? How many shuffles has that been? I can't shuffle and count and look at the camera at the same time. Anyway, when you are done, when you feel like your deck has been sufficiently randomized, I can guarantee you that what you're holding in your hands is a configuration of cards that has never before existed in the history of cards. Yeah, if you were to take a deck of cards and randomize it really fast, like a unique arrangement every second, since the beginning of time, and then you get to now, you wouldn't even be close to have created all of the arrangements possible. Math strikes again! 52 factorial was the first big, like, cosmically irrelevant number that I ever came across. So that explanation was good enough for me. But that actually doesn't even come close to the sheer massiveness that the number is. But Michael Stevens from Vsauce made a video showing how big that number is, and yeah, they did a good job of capturing my interest again. I'm sure you guys have heard an irrational number like pi, or the not number, infinity, go on forever and past the length of the universe or whatever, but this is a finite number that can be compared to the universe in terms of time, number of particles, distance, etc. A massive, yet finite number that I can hold in my hands. And that's why 52 factorial is my favorite mega number.